Hi Algebra 2. Today's video we're going to do part of lesson 3.1, which is direct variation, and part of lesson 3.3, which was writing equations. Both of these topics are things that you learned previously in algebra and geometry, so I'm just going to do a quick overview of them. Alright, so basically we can say that two variables are directly related or proportional if the following relationship holds. So if I have two variables, x and y, they have a direct proportional relationship if for every ordered pair x, y, we can say that y over x equals k or y equals k times x. And k is just the constant of variation. So all you're going to do on this, and we did these previously in earlier math classes, is you're going to make a proportion for each of these problems. You get to decide if you want y on top or x on top. I'm going to put y on top. So when y is 15, x is 5. Okay, and you can already see that constant of variation is going to be 3 because 15 over 5 is 3. Now I put y on top. I don't know what the y is, so I'm just going to call it y. And I have x is 9. So basically when y is 15, x is 5. I don't know what y is, but x is 9. I'm trying to find out what y is when x is 9. So I set up this proportion, and then I just cross multiply. So 5 times y is 5y. 15 times 9 is 135, and I divide by 5, and y equals 27. Okay, so for every single one of these, you're just setting up a proportion. So when y is negative 6, x is 4. I'm trying to figure out y when x is negative 10. Again, I'm just cross multiplying. 4 times y is 4y. Negative 6 times negative 10 is 60. Divided by 4, y is 15. And last one right here, when y is 12, x is 16. I'm trying to find y, x is 24. Again, you're just cross multiplying, so you're setting up a proportion for each of these. 12 times 24 is 288. Divided by 16, y is 18. We're just going to do the first page for this. All right, so the distance a person can travel varies directly with the time they have been traveling if going at a constant speed. Phoenix traveled 78 miles in 1.5 hours. So I got 78 miles, 1.5 hours. How far will he travel in 2 hours at the same speed? And I'll call this 2 hours. So I got distance over time, and then distance over time. If you wanted to, you could have just called that d for distance. It doesn't matter. I'm going to cross multiply, and I got 1.5 times x equals 78 times 2 is 156. So my distance is 104 miles. So I'm setting up a proportion to solve these. This is direct variation. And the last one, Jenna works at a job where her pay varies directly with the number of hours she worked. In 1 week, she worked 35 hours, and she made $274.75. So I'm going to put hours on top, and I'm going to put her pay on the bottom. How many hours would she need to work in order to earn $337.55? So I got hours over pay, hours over pay. And I'm just going to cross multiply, move this up a little bit. And I have 274.75H equals 35 times 337.55 is 11814.25 divided by 274.75. And she would have to work 43 hours. Okay, so that's my direct variation. Now we're going to go over to lesson 3, which is dealing with equations of lines. So you worked with this back in algebra and back in geometry last year. All right, so if I'm talking about linear functions, that's what this chapter is about, linear functions. There are two ways I can write an equation of a line. Back in algebra, we did y equals mx plus b. M is my slope, and b is my y-intercept. And in geometry, we did the point-slope form. We did a little bit of y equals mx plus b, but mostly my point-slope form. And m is still my slope, okay? And I use a point. So x1, y1 is the point on the line. So let's consider the linear function f of x equals 3x plus 5. I want to determine the y-intercept of this function by evaluating f of 0. So I'm just going to plug in 0 for x. So I have 3 times 0 plus 5. 3 times 0 is 0. So my y-intercept is just 5. Find the average rate of change. So that's something that we also did in this unit. So for a linear function, well, let's just do it out. So the average rate of change is going to be f of 3 minus f of negative 2 over 3 minus negative 2. So f of 3, okay, I'm plugging in 3. 3 times 3 is 9 plus 5 is 14. F of negative 2, I'm plugging in negative 2. 3 times negative 2 is negative 6 plus 5 is negative 1. So I'm subtracting that. F of 3 is 14 minus f of negative 2 is negative 1. And 3 minus negative 2 is going to be 5. So this is 15 over 5, which is 3. Okay, and hopefully you remember back from algebra and geometry, my slope is this number in front of the x. And if I have a linear function, my average rate of change is really just my slope. Okay, it's only when I have nonlinear functions that that average rate of change is different. For a linear function, that average rate of change is always going to be constant. All right, consider a line whose slope is 5 and which passes through the point negative 2, 8. Write the equation of the line in point slope form. So this is my x1, y1, and this is my slope. So all I'm doing is plugging those in. Y minus 8, because y1 is 8, equals my slope, which is 5, parentheses x minus x minus x1, and x1 happens to be negative 2, so x minus negative 2. So I can clean this up a little bit, and I'm just going to make it x plus 2. Now this is a perfectly acceptable answer. You can leave it like that. If you wanted to distribute that 5 to everything inside, you certainly could, and you can make it 5x plus 10. But the way it was originally written is perfectly fine. If you want to write it in slope-intercept form, then yes, you have to distribute that 5 to everything in the parentheses, and you get the 5x plus 10. And then all you're going to do is take that negative 8 and bring it over to the right by adding 8. And I get y equals 5x plus 18. Okay? Number 3 right here, which of the following represents an equation for a line that is parallel? Please remember that parallel lines have the same slope, and perpendicular lines, I have this on the next page, but we're actually not going to do that question. Perpendicular lines have slopes that are negative reciprocals. We'll probably try some in class that are perpendicular. Okay, and you should remember this was fairly easy from last year, so hopefully you remember all this. So I want to write an equation of a line that's parallel to y equals 3/2 x minus 7. If it's parallel, they have the same slope. So I'm looking for an equation that has a slope of 3/2. So I'm going to get rid of choice 1. It has the wrong slope. And I'm going to get rid of choice 4 because it has the wrong slope. Those would be if the lines were perpendicular, because those are negative reciprocals. But I am going to take that slope of 3/2 and this 0.6 negative 8, and I'm just going to write my equation. Remember, it's y minus y1 equals m parentheses x minus x1. So y minus negative 8 is really y plus 8 equals my slope, which is 3/2, and then x minus x1. So that is choice 3. Okay, and then I just wanted to look at one more. And that is going to be on exercise 6 right here. And I want to know which of the following equations could describe the graph of the linear function shown. All right. This is a positive slope. Okay, lines that start down and go up have a positive slope. So I definitely need something that's a positive slope. So I'm going to get rid of choice 2. I'm going to get rid of choice 4. Okay, and then my y-intercept, look at my y, this is my y-intercept right there. My y-intercept is a negative number because it's below 0. I don't know exactly what it is because there are not numbers on here, but my y-intercept is negative. And since it's negative, my answer is choice 3. Okay, if we have time tomorrow, we might look at 7, just because that sort of sums up a lot of stuff that we've done with domain and range and increasing and decreasing and one-to-one.